My name is Libera Fresiello, and I work as assistant professor at the University of Twente in the group of cardiovascular and respiratory physiology. So when I heard the news about winning the Professor of the Winter Award, I felt very honored and at the same time very excited about my research being recognized. So the first thing I did was to share the prize money with a PhD student, Maria Rocchi, who supported me in this activity. My research is about developing cardiovascular simulators that can support medical devices and therapies in general. So the idea is to use these simulators as test bench to assess the performance of medical devices and to improve innovation of medical devices. So this is a cardiovascular simulator. It includes a digital twin of the human body with the representation of heart and vessels on the computer, but it also includes an in vitro section where we reproduce the anatomical site of interest for the medical device to be tested. In this case, it is an aorta, but it can also be a cardiac chamber or a vena cava. The idea is that we connect the medical device in a realistic way as it would be in the clinics, and we can test the interaction of the medical device with the anatomical site of interest. But also, this anatomical site communicates with a digital twin, so we can also assess the effect of the medical device on the entire human body at a systemic level.
My name is Anneliene Jonker. I work here at the University of Twente within the group of HCSR. I work as an assistant professor on the topic of rare diseases, and more specifically, how can we develop the best therapies for people with rare diseases. I was super excited to win the Professor of the Winter Award, especially for this work that we've done with an international group of people from all over the world. I do not develop therapies myself. My research is about how can we develop therapies better. Together with an international group, we have investigated the very few therapies that exist for these very few cases, and looked at how can we actually learn from them. What are the elements that these therapy developments have in common? How can we do this better? Who is involved with it? And how can we actually set out a roadmap for each one of these? So the research actually looked into what are the different steps. How should you identify such a unique and special person that has a single mutation? How should you approach the conversation whether they would be willing and open to have a therapy developed for them? How should you compose a team together that can develop such a unique therapy? And then also, how do you actually develop the therapy themselves? How do you test it? How do you, if necessary, make sure that it's compliant with all the regulations out there? And then, if everything is in place, how do you actually administer therapy? But also, how do you make sure that the therapy is then followed over time, that patient is actually doing better? So we developed a roadmap for people with a very unique mutation, and with the ideas how to best develop, set out and test unique therapies for unique people. My big dream for the future is that more and more children with a rare and unique disease can actually be treated.